Alright, this is a review covering what we have learned so far about radical functions. We're going to graph them, talk about transformations, and solve equations. Please put your pencils down. If you're watching this video, it probably means that you're stuck on something and you need to learn how to do it. So put your pencil down. I'll show you how to do it. But then pick your pencil up afterwards and go back and do it by yourself. If you copy off of me as you follow along, you're going to think you know what you're doing, but you really don't. Alright, let's take a look at problem number one. Now, problem number one is one of those extra tricky ones because we have a reflection over the y-axis. When you have something going on here under the radical in the front like this, we're going to have to do it backwards. These are the ones where we start off with the y values and then get the x values from there. So usually when we do a square root function, we use the same four values. Usually we'll go 0, 1, 4, and 9. Alright? Because you can't take the square root of a negative number. And these are the first four numbers that have nice even square roots. We're not going to use these x values this time, but usually we use these. And then we will do the square root of the x values. So we would get 0, 1, 2, and 3. Alright, now we still want to end up with these y values, but the problem is these x values won't get us there because, like I said, we have this extra thing here. We have this negative in front. So we're not going to be doing the square root of x. We're doing the square root of negative x, or the opposite of x. So to figure out what x values will give us these y values, we need to set up a little equation. So for example, right here, the square root of negative x should equal 0 because that's the result that we want. So to figure out what x must be, of course we'll square both sides. So that would give us the square root of negative x is equal to 0. I'm sorry, we squared both sides, so that makes the radical go away. So we have negative x equals 0. And then, technically we're dividing both sides by negative 1. So that gives us x equals 0. Alright, so far that's the same. Now let's do the same thing for a y value of 1. If we want a y value of 1, that means the square root of negative x has to equal 1. So again, we square both sides. That will give us negative x equals 1. And then we will divide both sides by negative 1. And that will give me x equals negative 1. So that's the x value that will give us a y value of positive 1. Now let's do the same thing for 2. So if we want to get a y value of 2, let's see. Again, we square both sides, so that will give us negative x is equal to 4. Divide by negative 1, we'll get x equals negative 4. So we need an x value of negative 4 there. You can probably see where this is going, but we've only got one more to do. Because finally we want a y value of 3. So if the result is going to be 3, let's see what x needs to be. Square both sides, so that will give us negative x must equal 9. Dividing by negative 1 means that x must equal negative 9. Alright, so these are the x values that would give us the y values that we wanted. So again, you have to start with the y values anytime you have something horizontal happening here, either a horizontal stretch or a compression or a reflection over the y-axis. Anything happening in this position right here is when you have to start with the y values and get the x values by working backwards. Now, is this one of those where we need a third column? Yes. Because we have an a value, that's not 1. Anytime you have an a value like this, you're going to need a third column. So let's just add our third column on here really quickly. All right, and in that third column, that's where we multiply by the a value. Okay, so we're going to do a times y. Our a value is -2, so we're going to multiply these y values by -2. Okay, so that's going to give us 0, -2, -4, and -6. Okay, and once we have the new y values, we will disregard the old y values. You can just cross them out. So what we'll graph first will be x comma y, like the 0, 0, -1, -2, and so on. So graph these just as a skeleton, like a ghost. Do not connect these dots yet. 0, 0, -1, -2, -4, -4, and -9, -6. Okay, so that's what we have so far. Now, we have not done anything with the +1 or the +3 yet, so we need to understand what's happening there. Of course, the +1 inside the parentheses here is going to be, well, will it be a left or a right motion? Because we know it's going to be one of those. Yeah, it's going to be left 1, all right, because it'll be the opposite of what it sort of looks like when it's in there. Meanwhile, this out here is either up or down. Which is it? Yeah, that's up 3. That one works like normal. So it's going to be left 1 and up 3. So let's just take each one of these points and move them left 1 and up 3. Okay, so left 1, up 3. Left 1, up 3. Left 1, up 3. So this is the final answer. This is the starting point right here. So you'll start from here and draw your curve through it like this. And you should finish it off with a nice arrow. So that is how you graph one of these functions. Okay, now let's answer these questions. The starting point, they're referring to this point right here. So that is the point -1, 3. The domain is the x values, which go from -infinity to -1. Okay, we'll use a bracket because the function touches -1. It's not an asymptote or anything. Let's see, is there an absolute maximum or absolute minimum? There is an absolute maximum. That's the highest point right there. There's an absolute maximum of 3. Okay, so I'm just going to put a little line here. So there's an absolute max of 3, and there is no absolute minimum. I think I'll just say none. Over there. Okay, increasing or decreasing? This graph is increasing. Alright, I think I'll just circle it. The range is the y values, which go from -infinity up to a height of 3. And the -infinity must go first. So bottom to top, -infinity to 3. Okay, that's just empty. Now, end behavior. When we write this, we usually say as x approaches. Okay, so as x approaches, and we always start with -infinity because that means on the left. So as we go to the left, what happens to the y values? Down, 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 down. So as x approaches -infinity, f of x approaches also -infinity. As we go left, the y values go down. Okay, now how about the other one? I just have to squeeze in that as x approaches. Okay, as x approaches positive infinity, meaning as we head to the right, what happens to the y values? So as we head to the right, the y values go up, 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 but they dead end here at 3. So the y values are approaching 3. So that's the end behavior. Okay, and that is it for problem number 1. All right, problem number 2 is another one that has, this would be a horizontal stretch by a factor of 2 and a reflection over the y-axis. So again, whenever you have anything happening in this position right here, that's when you have to start with the y values and work your way back to the x values. So like I said before, usually we do x values of 0, 1, 4, and 9. Wait a minute. Oh, strike that. This is not a square root graph, this is a cube root graph. Okay, so when we do a cube root graph, we're thinking of what can we easily do the cube root of. So these are the x values we usually use. Don't copy off of me anyway, but definitely don't now because I'm going to erase this. Usually we do 0 and 1 and 8 and -1 and -8 because those are easy to take the cube root of. And usually in this column we do the cube root of those x values. So that would give us -2 and -1 and 0 and 1 and 2. Alright, the problem is we don't get to start with the cube root of x. We have to deal with this -1/2 that's in front. So we have to do the cube root of -1/2 x. Okay, we get to ignore the -2 and the +1 for now, but we have to deal with this. We have no choice. Okay, so we still want to get the same y values, but these x values won't give us the correct y values. So we're going to have to do different x values this time. To figure out what the x values are going to be, we are going to make little equations with these y values as the final answer. So in other words, if I want a y value of -2, then that means this expression has to equal -2. Okay? So now we can figure out what x value we need to make this happen. And the way we do that is we would have to cube both sides like this. Now if you cube both sides like that, the radical goes away. So you have -1/2 x is equal to -8. Okay? Now go ahead and look at this negative sign as being on the 2. We can put it anywhere we want, top, bottom, or middle. So I'm going to move it down there just to make my life easier. So to get x by itself, the easiest thing to do is to multiply both sides by -2. Alright, that way these will cancel out. So I will have x equals +16. So that's the x value that we need to get this y value. Now, how about if I want a y value of -1? Then this must equal -1. So let's solve this for x. So we would have to cube both sides, and that's going to give us -1/2 x is equal to -1. Alright, again, let's look at that negative sign as being on the 2. And let's multiply both sides by -2. Alright, so these -2's will cancel out, and that's going to give me x equals +2. So I need a +2 to get a y value of -1. Alright, now the rest of them I don't really need to do these equations over again, because if I want a y value of 0, you know the only thing that's going to give me 0 is 0. Now if I want to get a +1, I can just look back at this. If a 2 gives me a -1, then a -2 will give me a +1. Similarly, if I had a +16 before, this will be -16. Okay, so now I have my x values. Now, is this a problem where I'm going to need a third column? Let's see. Is there an a value? Nope, other than 1, there's no a value here. So I'm not going to need a third column. So I can just go ahead and graph these. But this will not be our final answer, so don't get too attached to these values. This will be a skeleton, do not connect the dots. Let's see. 16 and -2, that's pretty far off the chart, so I won't be able to graph that this time. So we'll have to just deal with these three values. So 2, -1. So I have 2, -1 be like here. See how far we're going to shift these things. Alright, yeah, so anyway, 2, -1. And then 0, 0, of course. And -2, 1. Okay, so we have this happening. Now remember, if I had graphed those other ones, it would have been 16, -2 would have been like over here someplace, maybe. Maybe I'll try to fake it. Like 1, 2, 3, 4. It would have been like here. You know, that's annoying me. Never mind. Okay, so I've got these 3 dots so far. You know what? I guess I will graph those as best I can. So understand, 16, -2 would have been like over here somewhere. -16, +2. Okay, here's +2. This is 10. So it's like off camera. -16 would have been like over here someplace. All right, I just want you to have a good idea of what this curve would have looked like. But we have to shift this anyway. So these points have to be shifted. The -2 is going to move us to the right by 2, and the +1 is going to move us up 1. So right 2, up 1. So if I take each one of these points and I move them right 2, up 1, okay, right 2, up 1, right 2, up 1. So there are those 3 points. Okay, if I move this right 2, up 1, it'd be like maybe about here. And if I move this right 2, up 1, it'd be like about here. Okay, so this is going to be the real graph. Is going to be doing something basically like this. Okay, and something basically like this. Okay, and that is how you graph number 2. Now let's answer the question that goes with it. Starting point. This graph doesn't really have a starting point. It has a point of inflection here at 2, 1. But I don't really think it has a starting point. How about, is it increasing or decreasing? Well, from left to right, this is going downhill the whole way. So it's decreasing. I'm just going to circle that. The domain. The domain is the x values. That goes left forever, right forever. So that's -infinity to positive infinity. Similarly, the range is the y values. It goes down forever and up forever. So once again, that is negative infinity to positive infinity. Does it have an absolute maximum or an absolute minimum? No, it doesn't have either one of those. Alright, I just said it goes up forever, down forever. So, no max, no min. Now, how about the end behavior? Now, as x approaches negative infinity, meaning as we go to the left, what happens to the y values? Alright, as we go to the left, the y values go up forever. So, f of x approaches positive infinity. Now, how about as x approaches positive infinity? In other words, as we go to the right, what happens to the y values? Well, as we go to the right, the y values go down, down, down. Okay, so f of x approaches negative infinity. Alright, so that is it for problem number 2. Alright, and this video is already 21 minutes long, so even though I've only done 2 problems, I'm going to stop this video here and continue on with another video. Let's hope that all of the problems don't take this long.